Why does the data path cycle have a huge impact on the performance of the CPU? So we dive into it. Okay. So data path cycle is a critical figuring out CPU overall performance between its governed and movement of data between diverse components of the processor, and language or insufficient statistic path can introduce bootling, lowering the overall pace and efficiency of the CPU. Here is why it has such a significant impact. 1. Data laundering and throughput. The record path is liable for shifting information between CPU components like registering, the Mad Good Judgment Unit, ALU, and CORG, and reminiscence. Is the fact section is language. Every coaching takes longer to finish due to the fact the statistic required for computation is not on time. This increases latency, the time to complete a single operation, and this is true put the full variety of operations completed through according to 2D. So critical path limitation is also part of the significant impact. The performance of the CPU is regularly confined with the aid of the lowest part of the fact direction called the initial direction. For example, if the connection between the couch and the CPU middles is language, every rapid ALU operation will be held up whilst awaiting fact to arrive. 3. Clock cycle dependency is also a significant impact. The pace of the record course impacts the CPU's clock cycle time. A longer statistics course approaches indicators to take more time to propagate, focusing the CPU to operate and decrease clock frequency to hold balance. Lower clock frequencies brings about fewer commands being achieved according to seconds, directly impacting performance. 4. Pipeline stale and hazard. Modern CPUs use pipelining to enhance overall performance, where couple of commands are accomplished simultaneously in unique pipeline levels. If the data decision is slow, it may motivate pipeline stall and or delay, wherein next instruction out to watch for facts for earlier ones, undermining the benefit of pipelining. 5. Power efficiency trade-off. An efficient data path can require more energy to drive signals across it, increasing power consumption, heat generation. Also, it, it can limit how fast a CPU can run without overheating or exceeding power budget, further reducing performance. 6. Memory bottleneck. The data path often extends to the memory hierarchy L1, L2, L3 cache, DRAM into brackets. If data transfer between memory and the CPU is slow, it creates a memory bottleneck, slowing down consumption regardless of how fast the CPU calls itself is. Summarize the optimization of mitigate data path issues. To limit the performance effect of statistic core cycle. CPU are designed with wider buses to move more statistics in parallel, shorter vital path by optimized layout and excessive speed interconnects. Efficient caching mechanization to lessen reliance on slower memories. Parallel statistics path for simultaneous operation, improving the information route cycle is crucial for achieving better CPU over performance, partic- particularly in modern day processor, wherein minimizing delays and minimizing throughput and paramount. So the second question, so we move to the second question, which is how does the CPU fetch, decode, and execute instructions? So the CPU performs a series of steps to process instructions, commonly referred to as fetch, decode, execute cycle. These steps are fundamental to how a CPU operates. Here is how each phase works. So one, fetch phase. The CPU retrieves the next instruction to execute from memory. Two, key some keys that are important are program counters, PC. The PC holds the address of the next instructions in memory. Instruction fetch. The CPU sends this address to memory and retrieves the instruction stored there. PC increment. The PC is updated to point to the next instruction, usually incremented by size of the instruction. The outcome. The instruction is loaded into the instructional register IR for processing. Decode phase. The CPU interprets the fetched instructions to determine what needs to be done. Key steps. These steps are very important in the code phase. Instruction phase. The CPU splits the instructions into parts such as operation code, OP code into brackets, and operand, example register, and memory addresses. Control signals. Based on the OP code, the CPU's control unit generates appropriate control signals to guide and execute. Operand fetch. This if the instructions require data, example, values from register or memory, the CPU identifies where to retrieve it. The outcome. The CPU understands the instructions and prepares the necessary components for execution. 3. Execute phase. The CPU performs the operation specified by the instruction. Key steps. ALU operation. If the instructions involve arithmetic or logic, the arithmetic logic unit ALU performs the required computation. Memory access. If the instructions require reading or writing to memory, the CPU interacts with the memory subsystem. Also, register updates. Results of operations are stored in the register or memory as specified by the instruction. Outcome. The operation is completed and CPU moves to the next instructions. Summary of fetch, decode, execute cycle. Fetch retrieves the subsequent preparation from data. Decode understands what the practice means and discover assets needed. Execute performs the operation and saves the end result. This cycle repeats continuously, ending the CPU to execute packets effectively. Thank you.